Hello friends, so welcome you all to yet another session on differentiation. Friends, today we are going to discuss the concept of successive differentiation. Okay, so we shall directly get on to the topic and see what is the concept of successive differentiation is. Are you ready? Okay then. Friends, if they have given you a function of the form y is equal to f of x. Consider the function y is equal to f of x. Now, in the previous classes and previous sessions, we have seen how to differentiate the function on different types. For example, if they have given the implicit function, or if they have given the logarithmic function or exponential function, or even parametric differentiation, logarithmic differentiation, we have seen so many concepts of differentiation. Today we are going to see the concept of successive differentiation. Successive differentiation means, as the word itself says, you differentiate more than once. Okay, so if I have y is equal to f of x as the given equation, okay, let me take it as equation 1, then the first derivative, okay, we have until now we have just dealt with the first derivative of the function. Okay, we know the first derivative of the function was denoted by dy by dx. Remember, this can also be written as y dash, means we are differentiating once, or you can also write it as y1, y suffix 1. Okay, this don't treat it as y power 1, this is y dash. Okay, and this is y1, okay, y suffix 1. This also means the first derivative. Okay, or else you can also call, if the function is given, you can also call it as f dash of x. So this is the way you represent the first derivative. Now if you go further, okay, the second derivative of the function, second derivative means actually you are going to get, we are going to differentiate what is already been differentiated, that is d by dx of dy by dx. Okay, remember this will be d square y by dx square. Okay, so the second derivative of the function is denoted by d square y by dx square, or you can represent this as y double dash, or you can also represent this as y2. Okay, as in the previous case, you can also write this as f double dash of x. Is it clear? F double dash of x. So in both the cases, remember, this is the second derivative. In the same case, if you take the third derivative of the same function, if you take the third derivative, this will be d cube y by dx cube. Okay, this is the third derivative of my function y. Say, or you can write it as y triple dash, or you can write it as y3. This is the most times we are going to use in this pattern. Okay, and very few times we will write f triple dash of x. Okay, now I've just gave you the concept of successive differentiation. Okay, you might be wondering what is all about it. Okay, now check here. If you take an example of as y is equal to, let me say, x power 10. Okay, if you take x power 10, okay, the first derivative is y dash. I told you first derivative is y dash. First derivative of x power 10 is, we know, 10 into x power 10 minus 1, that is 9. Okay, now similarly, if you go on for the second derivative, the second derivative of the same function is, now 10 is a constant. Okay, now the derivative of x power 9 is 9 into x power 8, isn't it? So this can be treated as 10 nines are 90, okay, into x power 8. Okay, so this is my second derivative. You can keep on differentiating as many times you want, or it is possible. So the third derivative will be 90 is a constant, keep it as it is. Derivative of x power 8 is 8 into x power 7. Okay, so this is nothing but you can multiply 8 nines are 72. So it is 720 into x power 7. Is it clear? So you can keep on differentiating this as many times as possible. Okay, now you can consider another example. Let me take another example, y, which is nothing but e power x. If I take e power x, you can see here the first derivative of this function is e power x. If you differentiate 2 times, that is y2 will also be e power x. If you take y3, that is the third derivative, this is third order derivative. Okay, first order, second order, third order derivative, even this will be e power x. Okay, now let me consider another function. Let me take the third one as y is equal to e power. If I take 3x, now consider what happens here. If I take y is equal to 3x, the first derivative will be, we know derivative of e power ax is a into e power ax. So it would be 3 into e power 3x. This is the first derivative. Now the second derivative will be, now this is already 3, this is multiplied, this is a constant, keep it aside, derivative of again e power 3x. So it is again 3 into e power 3x. Okay, so this is nothing but, you can write 3 into 3, 3 square into e power 3x. That is, if you take the derivative of e power 3x twice, it is 3 square into e power 3x. Similarly, if you take the derivative 3 times, that is the third derivative will be 3 cube into e power 3x. Okay, because again 3 will be multiplied. If you go on, the nth derivative of this will be 3 power n into e power 3x. I'm not going to go into the depth of this concept because you're going to see this concept in detail in your BSc classes. Okay, so don't worry about going up to the nth derivative of this function. Okay, let me take another example. Let me take the function, a trigonometric function. Let me take y is equal to sine x. See how beautifully this question changes now. Okay, now the question first derivative is y1, so, or you can write it as y dash. The first derivative is, when you differentiate sine once, you're going to get cos x. We know it, derivative of sine is cos. Now the second derivative of this will be, what is derivative of cos? We know derivative of cos is minus of sine. Is it clear? So the second derivative of sine is minus of sine. Now if you want to get the third derivative of this, minus is kept aside. What is derivative of sine? So this will be cos x. Okay, now let us take one more derivative. The fourth derivative of this function is, you derive this, find the derivative of this function once again. So y minus is already there, forget about this minus. Derivative of cos x will be again minus of sine x. Okay, so this will be minus of minus will be plus, so this will be sine x. Okay, so this is how you find the derivative of, called successive differentiation, means we are going to find the derivatives successively. Okay, until now we have just found out the first derivative of any given functions, but in this section and in this topic we are going to see the concept of successive differentiation. But for your topic and for second PUC, we are going to limit this successive differentiation for only the second order. That is, we are just going to find d square y by dx square, or y double dash, or y2. Okay, in your textbooks, in few questions they call it as d square y by dx square, or it is the second derivative of y. Okay, y double dash or y2. Is it clear? So now we are going to see directly the concept of second derivative, which is restricted to my second PUC syllabus. Okay. Okay friends, so we are going to deal the concept of second order derivative. Remember, this is a very important concept for you, because your 5-marker questions for your second PUC will be on this topic, that is second order derivative. You are going to have one question compulsory in this chapter on this topic only. Is it clear? So if you are thorough with second order derivative, then you can get 5 marks easily. The questions are also very simple, but only thing is you should have the clear picture or the clear idea of what the second order derivative of any function is. Okay, so until now we have seen the first order derivative. Only one new thing is we are going to go a step further and do it once again. Are you ready? We are going to solve the problems from, say, your exercise 5.7. Okay, the given function is y is equal to x power 20. Okay, so the first derivative, that is y dash, is, as I told you already, derivative of x power n is n into x power n minus 1, that is 20 into x power 19. Okay, now that second derivative of this will be 20 as it is. Again, derivative of x power 19 is, we all know, 19 into x power 18. Okay, so this is nothing but y dash will, second derivative will be 19 2s are 38. So 380 into x power 18. So remember, the second derivative of x power 20 is 380 into x power 18. Very simple, isn't it? Only thing is, these are very simple questions. You are not going to get these simple questions for 5 marks, but it would be advanced level problems. Okay, going on to the next one. So the next question I have is y is equal to x cos x. Okay, so the first derivative is, remember, it is a product of two functions, x into cos x. Okay, so keep first function as it is. Okay, derivative of cos is minus sine, remember, isn't it? Okay, plus cos x as it is. What is derivative of x? This is nothing but 1. Okay, so what I have, the first derivative is, actually first derivative is minus x into sin x plus cos x. Okay, so the first, I've got my first derivative. So the second derivative would be y double dash is nothing but, again here I have to use a product rule. Keep this minus outside. Now again keep x as it is. Derivative of sine will be cos x. Okay, plus now cos sin x as it is. Derivative of x will be 1. Okay, plus now what, check what is derivative of cos x. We know derivative of cos x is minus sin x, isn't it? So you can see what happens here. So this is nothing but minus of, or else you can, in both the terms I have minus common, take minus outside. So I will get x cos x plus sin x into 1, that is sin x, and I am going to add another sin x here because I have taken minus common here. Okay, so this is nothing but minus outside. I am going to get x cos x plus sin x plus sin x, that is nothing but 2 times sin x. So this will be my second order derivative. Okay, right? Did you understand this? I think it's very simple. So we shall move on to the next question. So consider the next question. I have y is equal to x cubed into log x. Okay, remember we are solving the exercise questions from exercise 5.7. So first derivative, that is y dash, would be, remember this is product of two functions, so keep x cubed as it is. Derivative of log x is 1 by x, isn't it? Plus now keep log x as it is. Derivative of x cubed will be 3x square. Okay, so you can write it in a simplified way. Y dash is nothing but, actually you will get x cubed by x, so that is nothing but x square. Okay, plus I'll write 3x square in front of log x, so 3x square into log x. Okay, so this is just the first order derivative, remember. Now the second order derivative, y double dash, is nothing but, what is derivative of x square? So derivative of x square will be 2x. Okay, plus now 3 is a constant, keep it outside. Okay, now again you have a product of two functions, x square into log x. Now keep first function as it is. Derivative log x, that is 1 by x, plus log x as it is, and derivative of x square would be 2x, isn't it? So we'll multiply. So y double dash would be 2x. Okay, plus now x square and x will be cancelled. One term of x would be cancelled. So let me cancel it and keep here. So 3 multiplied 3 to that. So x square by x is x, multiplied by 3 you will get 3 times x. Okay, plus now 2x into 3 will be 2 3s are 6x into log x. Okay, you can finally write this as y double dash is 2x plus 3x, that is nothing but 5x, plus 6x into log x. Okay, so this is how you find the second order derivative. Is it fine? So the next question I have is y is equal to e power x into sine 5x. So we can use the product rule here. So y dash, that is first derivative, is nothing but, keep first function as it is. Derivative of sine ax, we know derivative of sine ax is a cos ax, so 5 cos 5x. Okay, plus now keep sine function as it is, that is 5x, sine 5x. Now what is derivative of e power x? We know derivative of e power x is e power of x itself. Okay, now this can be written as, in both the terms I have e power of x common, so keep it outside. So I'll get 5 cos 5x plus sine 5x. Remember, this is my first order derivative. Is it clear? Now if you find the derivative of the second order, that is, if you differentiate this again this is sum, here this is sum of two functions, but this is treated as one function and e power x is one function, so it would be a product of two functions, Please be careful. So now second order derivative is keep first function as it is, that is e power x. Now differentiate this function. Okay. Now derivative of cos of ax is minus of, remember because derivative of cos is minus sign. So minus of, again 5 will be multiplied here. So I'll give 5 5s are 25 sine 5x, because derivative of cos ax is minus a cos minus a sine ax, and I already have 5. So 5 into 5 will be 25. Okay. Now plus sine 5x. What is derivative of sine 5x? So it is 5 cos 5x. Okay. So I've kept the first function as it is and differentiated the second one. Okay. Plus now you keep the second function as it is, that is 5 cos 5x plus sine 5x. Okay. Into differentiate e power x. We know derivative of e power x is e power of x itself. Okay. Now see what happens in both the terms. I have e power x common. Let us write the simplified form. Okay. So I have minus 25 sine 5x, isn't it? Plus 5 cos 5x. Okay. Next. Plus 5 cos 5x. Okay. Finally plus sine 5x, isn't it? So now simplify this. So this is nothing but e power x is common. Let me keep outside. Now first I'm going to write the sum of this. So 5 cos x plus 5 cos x will be, so 10 cos 5x. So 5 cos 5x plus 5 cos 5x is 10 cos 5x. Now it is minus 25 sine 5x plus sine 5x. So it would be minus 24 sine 5x. Okay. So this would be the second order derivative of the above given function. Is it fine? Okay. Now moving on to the next question. I have y is equal to tan inverse of x. Okay. So the first derivative is, we all know derivative of tan inverse is 1 divided by 1 plus x square, isn't it? So very simple question. Now if you differentiate this again, so y double dash is, this is of the form 1 by f of x. We know, we've already seen it, derivative of 1 by x is minus 1 by x square, isn't it? So derivative of 1 by f of x is minus 1 by f of x square, that is 1 by x square whole square into derivative of this 1 plus x square, that is d by dx of 1 plus x square. Okay. So this is nothing but minus 1 divided by 1 plus x square whole square into, now what is derivative of 1? We know derivative of 1 is 0. I'm not going to write it. Now derivative of x square is 2x. Okay. So finally you can write it in a most simplified form. So it is minus 1 into 2x is minus 2x divided by 1 plus x square whole square. Okay. This is my second order derivative of the function tan inverse x. Okay friends. Right. The next question we have is y is equal to e power 6x into cos 3x. Okay. So the first order derivative is, we know it's a product from product of two functions. We'll use product rule here. So keep first function as it is, that is e power 6x, differentiate cos 3x. We know derivative of cos ax is minus a sine ax. So that is minus 3 sine 3x. Okay. Plus keep cos 3x as it is. Okay. And what is derivative of e power 6x? So derivative of e power 6x is 6 into e power 6x, isn't it? So for our simplification, first order derivative y dash is nothing but, in both the terms I have e power 6x. Let me keep it outside. So sorry, e power 6x is kept outside. So I'm going to write this term first because it is positive. So it is 6 cos 3x, okay, minus 3 sine 3x. Okay, remember this is just the first order derivative. Okay. Now let me differentiate again. So the second derivative is y double dash is again product of two function. Keep e power 6x as it is, which is first function. Let me differentiate this. Now derivative of cos of 3x is, we know it is minus a sine 3x. So now if this 3 is multiplied to 6, I'll get 6 3s are 18 sine 3x. Okay, minus 3 is a constant. Okay, derivative of sine 3x is, you will get 3 cos 3x. So 3 3s are will be 9 cos 3x. Okay, sorry I overwrote it. Students, kindly don't do this thing in your examinations. Here anyhow it is nullified, but every time you should not overwrite it. Okay, plus now keep this function as it is, that is 6 cos 3x. Okay, minus 3 sine 3x. Now keep this function as it is. Derivative of e power 6 is 6 into e power 6x, isn't it? So let us write it in this most simplified form. So if you write e power 6x common term here, okay, so I have minus 18 sine 3x, okay, minus 9 cos 3x, isn't it? Now multiply this 6 into 6. What is 6 into 6? So it is plus 36 cos 3x, isn't it? Finally minus, what is 6 into 3? 6 3s are 18 sine 3x, right? So next see what happens. Final step, this is nothing but e power 6x. Okay, so I have 36 cos x minus 9 cos x. So 36 minus 9 will be 27 cos 3x. Okay, now plus 18 sin x plus 18 sin x, don't cancel because both are negatives. So it will be minus 36 sin 3x. Okay, so this is the derivative of the above given function. Next function I have is y is equal to log of log x. I hope you remember this formula. First derivative of log x is, it is 1 by x log x, isn't it? Let us check how. So derivative of log of f of x is 1 by f of x into derivative of log x. So that is 1 by x. So first derivative of log x is 1 by x log x. Okay, now the second derivative of this, so y double dash will be, now this is of the form 1 by f of x. Derivative of 1 by f of x is minus 1 by f of x square, that is minus 1 by x log x whole square into, remember you have to differentiate this function, what, x log x. So again you have to use a product rule here. Derivative of x log x is, keep first function as it is, derivative of log x is 1 by x, okay, plus log x as it is, derivative of x would be 1. Okay, now this would be, the second derivative is minus 1 divided by x log x whole square, and see what you are going to get. X and x will be cancelled. You will get 1 plus log x into 1 will be log x. Okay, finally you can write it in the simplified form as y double dash is nothing but minus of 1 plus log x divided by x log x whole square. Okay, so this is the second derivative of the function y is equal to log of log x. Let us move to the next question. I have y is equal to 3 power sin x. Okay, so first derivative is, it is of the form a power f of x. So derivative of e power f of x is a power f of x into log a into derivative of sine. We know derivative of sine will be cos x. Okay, so I have the first derivative y dash is nothing but log 3 into 3 power sin x into cos x. Okay, so now if you move on to the second derivative, okay, that is y double dash is nothing but, now you can keep this log 3 because this is constant outside, use a product rule here. Okay, so first function I'm going to keep as it is, that is e power sin x into, what is derivative of cos x? So derivative of cos x is minus sin x, isn't it? Okay, plus now I'm going to keep cos x as it is. Now what is derivative of 3 power sine x. Similarly, derivative of 3 power sine x is 3 power sine x, okay, into log 3, isn't it? Now finally, derivative of sine x. What is derivative of sine x? Sorry, it is plus cos x. Okay, so write it in a simplified form. You have log 3 into, okay, so let me write this term first. I have a log 3 term. Now cos into cos will be cos square x into 3 power sine x. Okay, now minus sine x into 3 power sine x into 3 power sine x. Okay, you can write it in a one last simplified form as, keep e power 3 power sine x common, so I'll write log 3 into 3 power sine x is a common term. I'm going to keep it outside, so I'm left over with log 3 into cos square x minus sine x. Okay, so this is the second derivative of the function 3 power sine x. Okay friends, so we'll move on to the one last question of the session. I have y is equal to sine of log x. Okay, so the first derivative of this will be derivative of sine of f of x is, we know it is cos of f of x into derivative of f of x. What? Derivative of log x is 1 by x. Actually this can be written as cos of log x divided by x. Okay, so remember this would be a quotient rule here, quotient function, cos of log x by x. So now if I'm going to do the second derivative, so second derivative y double dash is nothing but use a quotient rule. Okay, first in the numerator I'm going to keep x as it is and differentiate cos of log x. So derivative of cos of log x is minus sine of log x, isn't it, into differentiation of log x. So derivative of log x will be 1 by x. Okay, minus, because it's a quotient rule. Now keep cos of log x as it is, derivative of x. So derivative of x is 1 divided by denominator square. Okay, so this is nothing but, remember in both the terms I have minus outside, so I'm going to keep minus and multiply x to this. So if I multiply x, this x and x gets cancels, so I will going to have sine of log x and minus into plus will give me minus. I will have x into cos of log x, isn't it, divided by x square. Is it clear? Small correction friends. So when we kept first function as it is and differentiate this function, so this x is multiplied only for this term, it would not be multiplied here. So this x would be deleted, remember, because this x is only for this function, not here. So the final answer would be y double dash is equal to minus of, minus is a common term, sine of log x plus cos of log x divided by x square. Okay, so remember friends, this is the process of second order derivative. We have solved almost all the questions of simple questions. Okay, none of these questions have been asked in your examination, because from this type, from this part, you're going to get the 5 marker questions. Okay, practice these questions properly and go through the formulas once again, so that, and get ready for the next session where we would be dealing with the 5 mark questions for your examination. Okay, students, so keep learning, keep watching, keep enjoying, and keep moving ahead in your life. Thank you for watching this session. Hope you have understood this. So we'll meet again in the next session in the continuation of a second order derivative of 5 marks. Okay, so until then, take care and bye.